Hi everyone. Today is very auspicious day of Ram Navami, and we hope and we pray to Almighty that we all would be able and succeed in defeating this difficult and challenging time of COVID-19. So with this expectation and these praise to the God, we start our lecture. Today we shall solve some problems based on Z transform. In last video, we saw Z transforms of some important sequence and we found Z transform of unit step sequence and it was 1 and ROC of Z transform was entire Z plane. Then we also computed Z transform of an infinite duration sequence half to the power n un, and the Z transform calculated was 1 upon 1 minus half Z inverse, and ROC was mod Z greater than half. Now today we will solve some more problems. So first problem today which I shall take is minus half to the power n u of minus n minus 1. This is the sequence whose transform we shall find out. Now before drawing this sequence, let me explain what is this sequence u of minus n minus 1. And if you remember that in my previous video, I defined unit step sequence which is 1 for n greater and equal to 0 and it was 0 for n less than 0. And in general, it can be defined as u of n minus n naught is 1 for n minus n naught greater or equal to 0 and it is 0 for n minus n naught less than 0. So from this definition, I can write it is 1 for minus n minus 1 greater or equal to 0 and it is 0 for minus n minus 1 less than 0. What I have done, I have taken this argument minus n minus 1 and sequence is equated to 1 for argument greater or equal to 0 and sequence is equated to 0 for argument less than 0. So if I take this minus n in right hand side, what I shall get? I shall get this sequence is 1 for n less than minus 1. So this implies what? This I write on the next page. So u of minus n minus 1 is the sequence which is 1 for minus 1 less than or equal to n, or in other words for n great in other words for n less than or equal to minus 1 and it is 0 for n greater than minus 1. So if we plot this sequence, let it be the n axis. So it is 0 for n less than minus 1. So assume this point is minus 1. So at minus 1 the value of the sequence is 1, then at minus 2 it is 1, and so on. In the negative side, it is 1 till minus infinity. And for n equals 0, the sequence is what? 0. So I draw zeros with the help of green color. So it is 0 at 0, it is 0 at 1, it is 0 at 2, and so on. It is 0 for 0 onwards. So this is u of minus n minus 1. Now we have to draw this sequence. Which sequence? Our sequence under consideration is half to the power n u of minus n minus 1. And we already seen half to the power n is an exponentially decaying sequence which we had already drawn in previous video, but again I am drawing. It would be 1 at 0, and then in positive side it will be decaying, so it will be 1 by 2 at 1, then 1 by 2 is square at 2, and so on. And it will be growing in the negative side, means what? It would be at minus 1, it would be what? 2. At minus 2, it will be what? 4, and so on. So this sequence is half to the power n. Now if you multiply this two sequence, the red sequence is u of minus n minus 1. Now if these two sequences are multiplied, naturally for 0 onwards, the product of these two sequences would be 0, because u of minus n minus 1 is 0 for n greater than 0 and equal to 0, or in other words, for n greater than minus 1. Sequence would be non-zero only for n less than or equal to minus 1. So if we draw this sequence, how it will look like? The sequence would be like this. For 0 onwards, it is 0. So at 0, it is 0. At 1, it is 0. At 2, it is 0, and so on. I am drawing half to the power n u of minus n minus 1. Now, what it would be in negative side? At n equals minus 1, the value would be what? 2. So at minus 1, it is 2. At minus 2, the value would be what? 4. Or in other words, I can say it is 2 square. And at minus 3, it will be 8 or 2 cube, and so on. Now, I have given you the sequence minus half to the power n u of minus n minus 1. So you will negate this sequence, and when you will be negating, these positive samples would become negative. So this is now minus 2, this is now minus 4, and this is now minus 8. And there won't be any change in this positive side or 0 onward side. Here samples are 0. So this is the sequence given. And we have to obtain Z transform of this sequence. So what would be the Z transform of this sequence? Now if one wants to write this sequence into two pieces, how he or she can write? So half to the power n u of minus n minus 1 can be written as half to the power n for n less than or equal minus 1, and it is 0 for n greater than, is strictly greater than minus 1. So I can say greater or equal to 0. So this is the sequence. And now from the definition of Z transform, what is the definition of Z transform? Xz is summation over n. N is running from minus infinity to plus infinity. X of n, z to the power minus n. Now for this particular sequence, if I split this summation into two parts, one part from minus infinity to minus 1 and other part from 0 to infinity. So 0 onwards, the sequence is 0. Therefore, this summation will vanish and you will get 0. But this summation would be non-zero. So what would be this summation? This summation would be n from minus infinity to minus 1. And what is in this range? Xn, half to the power n, un, z to the power minus n. Now, if I combine this z and half terms, I can write n is from minus infinity to plus, minus infinity to minus 1, half z inverse to the power n. And if I make use of change of variables, if I take, let's say, n equals minus m, and I substitute in this summation, what? N equals minus m. So this summation would be what then? Then this summation would be xz. Now instead of n, there would be m, because n is minus m. So if n is minus infinity, m will be plus infinity. So m would be plus infinity. And when n is minus 1, m would be plus 1, half z inverse, and n is what? Minus m. Now I can take this m inside, this minus sign inside. Then what I shall get? Summation over m from plus infinity to 1. Then half inverse will become 2, and this will become z to the power m. Now if I reverse the limits, means if I change this limit, if I, in this summation, instead of writing from m infinity to 1, if I write m from 1 to infinity, will there any sign change? Because if you know, when there is an integration from a to b, fx dx, and if you change the limits of integration, let's say from b to a, fx dx, you get a negative sign outside the summation. So there, if you change the limits, there will be extra negative sign. But when you change the limit in summation, there won't be any negative sign. Why? Because let's say you want to add these three numbers in this direction. Let's say this is n equals 0 and this is, let's say, n is equals to 2. So summation, if you take from 0 to 2, so summation will be 1 plus 2 plus 3, that is 6. But if you add from right hand side, that is from n equals 2 to n equals to 0, then also summation would be 6. It won't be minus 6. So in case of summation, if you change the limits, there won't be any change of sign. So from this summation would be m from 1 to infinity 2z to the power m. And there was a negative sign. So this negative sign I can put here. Now if you expand this summation, what you get? You get 2z plus 2z to the power 1 plus 2z to the power 2 and so on. Now again you can see it is an infinite GP, and the summation of infinite GP is what? We know first term is what? 2z upon 1 minus common ratio. And what is the common ratio? 2z. But when this common ratio, that is what? 2z mod is strictly less than 1. So we get this is 2z upon 1 minus, and this minus sign is here. You should not forget this minus sign. This is outside here. And then what we get? Mod 2 into mod z is less than 1. Now if I divide numerator and denominator by 2z, what I get? 1 upon 1 upon 2z minus 1, and the minus sign is here. For what? For mod z is strictly less than half. In other words, what you get, I write on the next page. So this x of z is, it is 1 upon 1 minus half z inverse. I have absorbed this minus sign inside, and mod z is less than half. You just see this, what I have done. This minus sign I have taken inside. So this minus 1 becomes plus, and this half, this 1 by 2z becomes minus 1 by 2z. That I have written half z inverse. So this is the z transform of the sequence minus half to the power n. Sorry, this is z transform of minus half to the power n u of minus n minus 1. And what it is? It is 1 minus half z inverse for mod z less than half. Now if I draw the ROC of this xz, what it would be? So this is my z plane, this is real part of z, this is the imaginary part of z axis. Now what would be the ROC? ROC is mod z is strictly less than half. So first I have to draw a circle of radius half. So this is the circle of radius half. And what is the ROC? Less than half means this region would be inside or the interior to this circle. So this green region is what? Our ROC. So ROC is interior to this circle of radius half. Now if you compare the Z transform of these two sequences, which two sequences? In previous lecture we saw Z transform of this sequence half to the power n un, and we obtained it was 1 upon 1 minus half z inverse for mod z greater than half. So ROC was exterior to the circle of radius of half. And today we saw that Z transform of this sequence minus half u of minus n minus 1. Z transform of this sequence is 1 upon 1 minus half z inverse for mod z less than half. Now it is important to note that these two sequences are altogether different, but their Z transforms expressions are coming same. So what does it indicate? Does it indicate that two different sequences can have the same Z transform? No, the Z transform is not the same. Why? Though the expressions are same, but their ROCs are different. So we can say for two different sequence, Z transform can't be the same. The Z transform would be unique. So with this, I stop here. Thank you very much.